Okay, gentlemen, here we go with 5.5 day 2 factoring quadratic expressions in the form ax squared plus bx plus c. In this case, the a value is 1. What is a quadratic expression? Provide an example. Well, a quadratic expression is basically a mathematical expression. Whose degree. An example of that would be 2x squared plus 7x plus 5. There's an example. Provide, you know what, let me try something different here, by the way. I want that to go there, maybe down here. Mathematical, whose degree is 2. I'm a little neater than what I wrote before. Provide an example of a trinomial that cannot be factored. Explain why. So a trinomial that can't be factored, how about x squared plus 24x plus 5? Because there are no factors. Let's add a text box here. No factors. That didn't go as well as I planned. Let's try that. No factors of 5 that have a sum of 24. So there are no factors of 5 that have a sum of 24. So we know the factors of 5 are 1 and 5, so we can't add those two together and get 24. That's really what we're saying here. Okay, erasing that as well. Factor this fully. Well, first thing you always want to look for is a GCF. In this case, there is no GCF because 22 can be divisible by 2, but 21 cannot. So there's no GCF. Another way of saying the next step that we need to do here is multiply A. So we learned last time that this is our A value, this is our B value, that's our C value. We want to multiply A times C, which in this case is 8 times negative 21. And the answer to that is, or the product is negative 168. Okay. So we're looking for two numbers that multiply to negative 168 and add up to positive 22. You may use your calculator and start just playing with the numbers a little bit and seeing 168 divided by 2, 3, 4, etc. And what you'll end up getting is positive 28, and negative 6. So what we're going to do now is we're going to rewrite our equation by breaking down the middle term. So I'll have 8x squared plus 28x minus 6x minus 21. And we learned in previous lessons that now we can factor this by grouping these together and looking for the GCF in each. So the greatest common factor between 8x squared and 28 is 4 for the numerical coefficient and x for the variables. We could take a 4x out of each. 4x, well, the 4 times 2 is 8, and x times x will be x squared. So 4x times 2x is 8x squared. And remember, you can take 8x squared and divide it by the greatest common factor, and you'll be left with 2x. So it's another way of trying to figure out what you put in the brackets, taking the 8x squared, dividing it by the GCF, in this case is 4x, and you'll get 2x. And the next step would be, so 4x or 28x divided by 4x would be positive 7. Here we have numerically between the 6 and the 21, we know both numbers are divisible by 3. So I want to take out a negative 3. And this is something to keep an eye out for. So if I take out a negative 3, look what happens in the bracket. Negative 3 times 2x gets me negative 6x, and a negative 3 times a positive 7 will get me negative 21. In this case, now I have a positive 2x plus 7 on each bracket. If we took out a positive 3, we'd have opposite integers inside the brackets, and that would be a step you'd have to redo, because the point here is so that you get the same binomial within the brackets. And now we can simplify this further by saying we have 2x plus 7 being multiplied by a 4x and as well by a negative 3. And there we're done. You can try the next couple on your own if you want to pause the video here. And then you can follow the steps as I do them. So I'll move a little more quickly here. Again, here there's no GCF. A times C is equal to 3 times 2, which is 6. And now we're looking for two numbers that multiply to 6 and add up to 7. Well, then we're left with a positive 6 and a positive 1. So we rewrite this equation, 3x squared plus 6x plus, we're not going to write the 1, we'll just write plus x plus 2y squared. And now we'll take out a GCF between these two terms, and that is going to be a 3x. So 3x times x is 3x squared, and 3x times a positive 2 would get you positive 6x. And in the next set here, there actually is, did I make a mistake? Oh, I did make a mistake. Oops. Follow me here for a second. What I did, my mistake was, and I should highlight this in pink because you'll recognize it. The middle term is 7xy. I forgot to put the y here. So that's positive 6xy plus xy. In this case, when we take out our GCF of 3x, we're going to multiply by x plus 2y. And what we have here in common is a positive y for these two here. So we take out a y times x plus 2y. So y times x is xy, and y times 2y is 2y squared. And what we have in brackets is the exact same thing, x plus 2y. So I have x plus 2y times 3x plus y. Done. The next example is a little bit different. There is a GCF here. So here we have a GCF is 2. So let's remove the GCF. 2 times 2x squared plus 7xy plus 3y squared. So you'll notice we only had a 2. There were no variables in common. We have an x squared here, we have an xy, but there's no x's here, so we can't take out an x, and we can't take a y out from each of those terms. So we can only take a 2 out. And now we're going to leave this 2 out and basically do what we've done with the other questions. We know there aren't two numbers that multiply by 3 and add up to 7. We're multiplying a times c. So in this case, 2 times 3. So 2a times c is equal to 2 times 3, which is 6. Two numbers that multiply to 6 and add up to 7. And they're 6 and 1, or 1 and 6. And they're both positive, so we're going to use positive 6 and a positive 1. So in this case, we'll write 2x squared, and we're breaking down this middle term. And we're going to use positive 6xy, don't forget the y, plus xy plus 3y squared. And now, looking at factoring by grouping, the greatest common factor between 2x squared and 6xy is a 2x. Again, times x plus 2x times 3y will get me 6xy. And here we're taking out a y. And we're going to multiply by x plus 3y. You take a look and you say, oh yeah, I got the same binomial. And so now we can write 2 times x plus 3y times 2x plus y, and we're done, which is really root form, and we know that's a equal 2, which is a stretch. I'm just pointing that out. It's not something you have to write, but I just want to point that out. What shape is y equal x squared minus 6x plus 5? So here's a mathematical expression, and the degree is 2 because we have an exponent 2 here. There's an exponent 1 there. And as we learned above, a quadratic expression is a mathematical expression whose degree is 2. And so that's a quadratic expression, and the shape of that graph would be parabolic. It's a parabola, and the shape is called parabolic. Can you graph it easy when it's written like this? Well, when it's written like that, not really. So no. All we have here is the y-intercept, which is 5, right? If you plug in 0 for x, you get 0 squared, which is 0, minus 6 times 0, which is 0, plus 5. So when x is 0, y is equal to 5. So all you have is the y-intercept. There's not much else to go on there. So that's the explanation. All we have is the y-intercept. If you factored it in this form, which is root form, would it be easier to graph? Absolutely. So yes. And explaining why, I will use this, because we can graph the roots, the vertex, and can calculate the y. We already know the y-intercept. You can calculate that too. Y-intercept. Intercept. Let them work out. Intercept. As well. Okay, because we can graph the roots, the vertex, and can calculate the y-intercept as well. So you have many more points in order to get an accurate plotting of your parabola, and this way a better sketch, of course. Okay, and I think that's pretty much it. All right, we'll see you in class. Good luck with your homework, or sorry, that was your homework. Well, good luck in class, and we'll see you.